There are these creatures that came from off-world. These are untouchables. NASA, notable for its essential openings, has indeed uncovered that this new planet is not just enchanting due to its size and location but also because it displays lights that appear to be artificial. Are we, in essence, uncovering insider truths that could significantly alter our perspective on the universe? Could this revelation ultimately mean there is life on other planets? Join us as we explore NASA's astonishing discoveries and uncover the truth about these mysterious lights. In 2007, NASA launched the Dawn spacecraft with a mission to study the most captivating objects in our solar system. Equipped with 3 ion engines, Dawn embarked on a remarkable journey. Its mission began with a 14-month investigation of Vesta, the second-largest asteroid in the belt. During this time, Dawn sent back detailed images and data, revealing Vesta's rugged surface and various geological features. After completing its primary objective at Vesta, Dawn set out on the second and perhaps most fascinating part of its mission, a close examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and embark on a journey to reach Ceres, an achievement that conventional chemical propulsion would have found challenging. These engines, providing a steady, gentle thrust, enabled Dawn to travel vast distances efficiently and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For a long time, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of approximately 950 kilometers, Ceres is the largest and most massive body in the asteroid belt and one of the most intriguing due to its unique characteristics. As Dawn approached Ceres, scientists eagerly anticipated the first detailed images of this enigmatic world. They observed bright spots scattered across its surface, most notably in a large depression now known as a crater. These bright spots ignited intense interest and speculation among scientists. Before Dawn's mission, the best image we had of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. Scientists knew very little about this dwarf planet, and the prospect of finally obtaining a close-up view was exhilarating. What mysteries would Ceres reveal? What new discoveries awaited the mission? Dawn promised to enhance our understanding of the solar system's evolution and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of highly reflective material, possibly salts left behind by sublimated water. This raised the possibility of cryovolcanism on Ceres, a process where volcanoes emit water or briny liquids instead of molten rock. But what exactly are these mysterious lights, and what do they reveal about Ceres? Could they be evidence of ongoing geological activity or something far more extraordinary? Ceres stands out from other celestial bodies in the asteroid belt due to its size, mass, composition, and potential for water and ice. Unlike most rocky asteroids, Ceres has a composition more akin to a comet, suggesting it holds more secrets about the early solar system than we ever imagined. After 2 years on its journey, the Dawn spacecraft finally approached Ceres in early 2015. This milestone marked a significant achievement in the mission, as Dawn provided humanity's first close-up views of the largest object in the asteroid belt. As Dawn moved closer, the images of Ceres became increasingly detailed, offering glimpses of a world previously shrouded in mystery. The initial images revealed a surface pocked with craters, indicative of a long history of impacts. However, it wasn't the craters that captured the attention of scientists and space enthusiasts alike. Among these features were unusual bright spots that stood out starkly against the darker, rugged terrain. As the photographs continued to improve in resolution, scientists buzzed with theories about the nature of these bright spots. Were they ice patches reflecting sunlight, or could they be something even more intriguing? Hypotheses ranged from mineral deposits to potential signs of cryovolcanic activity. Closer examination revealed that the brightest spot was not a single feature, but rather a cluster of several distinct areas. This discovery only deepened the mystery. The idea that these were deposits of salts left behind by sublimating water gained traction. This would suggest that Ceres had, or still has, some form of geological activity capable of bringing water or briny liquids to the surface, where they quickly evaporate, leaving behind bright, reflective deposits. These findings challenged existing theories about Ceres, revealing it to be a more complex and dynamic world than previously thought. The presence of such features raised the possibility of subsurface water or briny pockets, which could have significant implications for our understanding of the potential for life in our solar system. But what makes Ceres so significant compared to other planets? Ceres is a fascinating world, often described as a cold planet with a harsh yet delicate surface. Unlike most asteroids in the belt, which are primarily composed of rock and metals, Ceres stands out due to its unique composition. Its surface is a combination of water, ice, and hydrated minerals, including muds and carbonates, which gives it a fundamentally less dense construction compared to its neighbors. This composition suggests that Ceres contains a significant amount of water. The surface layer is rough yet porous, with ice and other volatiles trapped within. This cold characteristic is more reminiscent of a comet than a typical asteroid, hinting at a history that may have involved a mix of rocky and icy materials. Digging deeper beneath its surface, Ceres reveals even more intriguing aspects of its structure. The dwarf planet is believed to have a differentiated interior consisting of a slushy mantle and a core. The mantle is thought to be rich in water ice, making up about half of Ceres' total volume. This mantle, possibly a mix of rock and salty water, surrounds a core that may consist of denser materials, perhaps silicates. The presence of so much water ice suggests that Ceres might have once held liquid water, particularly if its core was heated by radioactive decay in its early history. This internal structure sets Ceres apart from its asteroid neighbors and raises fascinating questions about its potential for geological activity and the role of water in its development. However, that's not all. The discovery of ammonia clays on Ceres suggests that the dwarf planet may have formed in a colder region of the solar system before migrating inward. The presence of ammonia lowers the freezing point of water, supporting the idea of subsurface brines. These insights into Ceres' structure and history not only enhance our understanding of this fascinating dwarf planet, but also provide critical clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a captivating and somewhat exotic geological process, especially when compared to the more familiar volcanic activity on Earth. Unlike conventional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, release volatiles like water, ammonia, or methane. These substances can exist as liquids or gases in the extremely cold conditions where cryovolcanoes are found. On Ceres, cryovolcanoes work by allowing water mixed with dissolved salts to reach the surface. When this briny water interacts with the vacuum of space, it rapidly evaporates, transitioning directly from a solid or liquid state to a gas, leaving behind bright, reflective salt deposits. These salt deposits form the mysterious bright spots observed on Ceres' surface. The most famous of these bright spots is located in a crater known as a crater, specifically in an area referred to as Spot 5. This location has attracted significant attention due to its high reflectivity and unusual hazes observed by the Dawn spacecraft. These hazes are believed to be caused by the sublimation of water, suggesting that cryovolcanic activity may still be ongoing or might have occurred relatively recently. Furthermore, Ceres has several other bright spots, each with its own unique properties. These spots are not confined to one region but are scattered across the dwarf planet's surface, indicating that cryovolcanism might be a widespread phenomenon on Ceres. The presence of these bright spots highlights the unique nature of Ceres and raises important questions about the potential for life in our solar system. The dynamic and evolving nature of Ceres challenges previous assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, a wealth of surface features began to emerge. The outer surface of Ceres is pitted with various craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, indicating an ancient surface that has been subjected to numerous impacts over billions of years. Others are better preserved, with sharp edges and deep basins, suggesting more recent impacts. Interestingly, the number of craters on Ceres is fewer than initially expected, which might indicate that geological processes are renewing the planet and erasing evidence of older impacts. One theory is that Ceres' icy surface allows for a type of cryovolcanic resurfacing, where subsurface materials occasionally well up and cover older features. This ongoing geological activity suggests that Ceres is not a static world but one that has been, and may still be, actively evolving. Additional evidence of surface deformation on Ceres comes from the observation of fractures, ridges, and faults on its surface. These features indicate that Ceres' crust has experienced significant stress and stretching. Some of the fractures appear to be relatively young, perhaps only a few 100 million years old. Such features imply that the dwarf planet has undergone episodes of internal heating, likely caused by radioactive decay or tidal interactions with nearby celestial bodies. This combination of features, bright spots, craters, and surface deformation, suggests that Ceres has experienced a complex history of geological processes, including the potential for both past and ongoing cryovolcanism. These discoveries are significant not only for understanding Ceres but also for expanding our knowledge of planetary evolution and the potential for life beyond Earth. Could Ceres' icy surface and subsurface water hold the keys to extraterrestrial life? The evidence remains inconclusive, but it's clear that Ceres is a world full of surprises and mysteries still waiting to be uncovered. In conclusion, the bright spots on Ceres offer a tantalizing glimpse into the intricate and evolving nature of this dwarf planet. With its potential for cryovolcanic activity, subsurface water, and geological resurfacing, Ceres is more than just a frozen relic of the early solar system. It is a dynamic world that challenges our assumptions and opens up exciting new avenues for exploration. As the Dawn spacecraft continues its observations, it may yet reveal more secrets hidden beneath the icy surface of this distant world. The journey to uncover the mysteries of Ceres is far from over. The Dawn spacecraft, having completed its primary mission, continues to provide critical data that will keep researchers busy for years to come. Even though the spacecraft has now moved on to other missions, the legacy of its exploration of Ceres lives on. As scientists continue to analyze the data sent back by Dawn, new discoveries may surface, offering fresh insights into the nature of this dwarf planet. The bright spots, cryovolcanic activity, and complex surface features observed by Dawn challenge our assumptions about how celestial bodies evolve, especially in cold, distant regions of our solar system.